Hi everyone and welcome to the Anima Maestro Composer video series. This series will focus on the development of my animatronic control software, which can animate robots and animatronics through all sorts of hardware. In this first video, I'm going to give you a tour of the application. Welcome to Anima Maestro. Hi everyone and welcome again to the channel. Welcome to this brand new video series which will talk about the development of Anima Maestro Composer, the application that I developed to configure, control and animate my animatronic. At the heart of my animatronic project are a few important electronic circuits and devices that I developed over the years. The first one, and arguably the most important one, is called Anima Maestro Conductor. It is a small computer that I designed and assembled to manage the playback of animation and audio for my animatronic. In order to drive all the servo motors of my animatronic, as well as the lighting and audio amplifiers that are included in the project, I also designed and assembled electronic PCBs that I call Anima Maestro units. And finally, to power the units, as well as to arbitrate the communication between the units and the conductor, I also developed the Anima Maestro controllers electronic PCBs. So in order to test, control and configure all these pieces of hardware, I had to write some software along the way. And as the years passed and the software that I wrote was evolving, it started to look more and more like a genuine animation application. And now I believe that it has perhaps the potential to become a full show control software. So I am putting a lot of effort in the design to make it as modular as possible using a plug-and-base architecture. So as you will see later in the video, the Anima Maestro Composer can control animatronics and robots through my Anima Maestro hardware, but can also animate servo motors using other hardware such as Pololu Maestro servo controllers or Arduino boards. In the future, I want to keep adding support for more types of hardware, such as DMX controllers, for example, to allow Anima Maestro Composer to animate virtually any type of stage show equipment. So without further ado, let's begin our tour. So here it is, here is the application. So the first thing that we can see on the upper left corner of the application is the list of what I call device suites. So a suite is basically a driver that communicates with the hardware and software that the composer can configure and control. So my application is written in C#. It is currently a WinForms application, but I plan to transition to WPF eventually. So in this context, all suites are actually plugins that are developed based on a C# object-oriented API that the Composer application exposes. This means that I can write plugins to control virtually anything, such as Arduino boards hardware or Fusion 360 software, which I will both demonstrate in this video. But right now, let's select the Anima Maestro Conductor suite. Let's enable it. It's now asking me to turn on the Anima Maestro Conductor, which I will do. It's now asking me to activate the link. So it is properly connected. So the first thing that we notice is that the Anima Maestro Conductor suite provides both the animatronic setup and storage setup management forms. So let's take a look at the animatronic setup. So now we can see that the suite has currently detected 8 units. We can also see that these 8 units are powered and coordinated by 2 controllers, the primary controller as well as the secondary controller. For both controllers, we can see some status information such as the voltage rails as well as the temperatures and fan speeds inside the stage box. So if you want to learn more about it, you can take a look at my Anima Maestro Stage Box video series. So let's select a unit. Let's take a look at unit number 3 here. So here you have a typical Anima Maestro PWM unit. Each unit can control up to 8 DC motors with position sensors that we can see here, or the unit can control 16 standard RC servo motors, or actually any device that can be controlled using a PWM signal. On the top of the form here, we can see some status information. So we can see that if I start the unit, it is actually confirmed here. So we can now take a look at module 0 here and notice that it is currently set up to use 12 volt power and a 400 Hz PWM signal. Port A is currently configured to control my animatronic right knee. So if I open the configuration box, we can see here all the technical settings that are required to control the knee, such as sensor information and PID controller information. But if the port was set up to control a standard RC servo motor, the only thing that you would have would be the command here where you would set the minimum and maximum for the servo. But the most interesting and important thing that you can set up in the configuration of a port is actually its units, upper and lower limits, which are the actual values that will be animated. So we can now close this form, enable the unit and see that it is now properly enabled. And now if I change the position of the knee, we can actually see it moving. Let's now disable and stop this unit and try to look at another one. So we'll look at unit 1 here, which is a NeoPixel controller unit. Let's start it. So here we see a NeoPixel strip, and this strip is currently controlled by module number 2. The first pattern generator is controlling 60 NeoPixels. So if I open its configuration form, we can see that the pattern is set to lines, which are oscillating through a wave generator. The number of pixels per line is set up by port number 3, and the brightness of the pixels is set up by port number 5. So if I enable and synchronize the unit, we can see the NeoPixel start animating. So if I open the module brightness control, we can actually see that if I increase the brightness increases. And if I open the line length control, I can actually change the length of the lines. So once your animatronic is properly configured, it is now time to actually start animating it. So to do so, you have to create an animation sequence. So let's create a new one here. So this is the form where you set up your sequence and where you manage all the tracks and the animation controls. So let me set up a basic sequence here and I will detail the tracks and the animation controls as we go on. So let's name this sequence Demo. It's a 1 minute long sequence. Let's insert a video track. Let's add one audio track. Let's also add a leg controller here. Select it. Then we can bind the knee controls to the actual physical knees. So left knee link, right knee link. Let's now add an animation controller for the NeoPixel's line length, insert simple port, as well as for the pixel's brightness, insert simple port. We can now add finally a color picker and link its color to the NeoPixel's color. We're all set, so we just created our basic sequence. So there we can see all the tracks that we created as well as all the animation controllers. So the first track that we see in the application is called the timeline track. So as you can see, we can move the editing position bar. and see the editing position being updated here. So the editing position shows hours, minutes, seconds, and frames. The Anima Maestro Composer application works at 60 frames per second or 60p. So on the timeline track, we can add markers. So they can help us pinpoint specific locations in our sequence. So if I double click, I can name it beginning. If I enable the snap feature, we can see that if I move the editing position, it can actually snap to the markers or actually any other important event that are on the tracks. Next, let's import some audio and video files. Let's add video. So here, the same thing, we can see that as I move the video, it can snap either to the editing position bar or to the marker. So let's drop it there. So the purpose of the video track is to provide you with a video reference to help you during your animation process. So now if I scrub the timeline, I can see the video playing in the video monitor. So now let's add audio. Once again, I can align it using the marker and the snap feature. Now let's expand the audio track and zoom in a little bit to find out some specific events and add some markers. Here. And here. Now we can take a look at the animation tracks. So the animation tracks represent the evolution of a parameter over time, and the parameter is represented by a curve. And we define the shape of the curve using keyframes and interpolation. So let's set up some keyframes. First, let's set up the knees to fully bent. Let's select a NeoPixel line length of about 5 or 6 pixels. Set up the brightness to 100%, and let's choose a startup color, for example, red. Now let's move to the first marker. Add the same keyframes. Move to the second marker and unbend the knee. Move to the next marker. Add a keyframe again. And finally, the last marker. Let's bend the knee again and select another color, which in this case, I'm gonna pick this blue here. So as we can see here, we have a curve that represents how the knees are bending. So if I expand it and zoom in, I can change the shape of the curve by editing the keyframe, and I can choose to have no interpolation at all, linear interpolation, continuous spline, or broken spline. The next thing that I would like to show you here is if I start the live edit mode, you can actually have your animatronic powered while you edit the keyframes. Now let's turn it off and get rid of these keyframes here. And we can now take a look at our animation. So there we are. We can see that the knees and the NeoPixels color are following our animation. So if we are happy with how the knees are performing here, we can decide that we select this animation here of the knees and actually save it. Good knee action. And there we have our action here, so we can take it and add it later on the timeline if we like. The last thing that I would like to show you is that I also included in the application a webcam monitor. So as you can see here, if your webcam is pointing at your animatronic and you have a video on the video track, you can see them side by side and it can help you set up your animations. But this mode is even more useful if you have a dual setup monitor, because you can expand your application here on both monitors. And as you can see, you have a much better view and you also have more space for your animation tracks. So we are now done with our first animation sequence. So let's save it, close it, and disable the Anima Maestro Conductor suite, so that we can now take a look at the Anima Maestro Arduino suite. Let's enable the suite. We see that it's now connected. Let's look at the animatronic setup form. So here we can see that there are 3 serial ports on this computer, COM1, COM3 and COM4. We see that COM3 and COM4 are currently selected and connected to Arduino boards. So here is my animatronic head, and as you can see, there are 2 Arduino Nano boards at the bottom left of your screen. The one in front is connected to COM4 and is currently not configured, and the one at the back is connected to COM3 and is actually configured to control my animatronic eyes and eyelids. So if we look at COM4 here, we can see the unconfigured board, but if I start it and enable it, we see that it is responding properly. If we now take a look at COM3, we see that it is configured to control my Anima Maestro eyes and eyelids. So if we start and enable the board, we can see that it is working and configured for the 8 servo motors. And if I move the slider, we can see that the eye is moving accordingly. Let's go back to the default and take a quick look at the configuration form. So we can see that this servo is actually controlling the left eye lateral movement. It is assigned to pin D5 on the Arduino Nano board. The servo is set up here, and the actual values and units that are displayed on the animation track are configured here. So now that the Arduino boards are properly configured, we can make some animation. So let's create a new sequence. Let's add an eye controller, and let me set it up quickly. So there we go. So we can see that we have our eye controller here with the animation tracks over there. So if I turn on Live Edit, we can start animating our animatronic. Up and down. Left and right. Even cross-side. Eyelids open, closed. Can move the aperture up and down. And even blink. So let's take a quick look at an animation. and play it back. So there we can see that my Anima Maestro Composer application is able to control and animate servo motors using Arduino boards. So this is basically what my application can do so far. So my plans for the future are to port the application to WPF to improve performances, as well as add support for more audio and video formats. I also want to refactor the sequence setup form. What I want to do is take all the track management as well as animation controller management out of the form and bring them to this empty space here at the bottom left corner of the application. Another thing that I want to do is to improve the keyframe and curve editing capabilities of the application, as well as improve the interpolation algorithms. I also want to add the possibility to save keyframe actions that span more than one animation controller. But there is really one big feature that I would really want to add and that I've been looking for many years is the possibility to have a virtual 3D representation of the animatronic. So if you had such a virtual 3D representation, you could work offline and being able to work on your animation without having the hardware. So that is really something that I would want to integrate. I've tried to do such an integration with Fusion 360. So here is a demo of a somewhat successful attempt that I made some time ago to integrate my Anima Maestro Composer application with Autodesk Fusion 360. So as you can see here, Anima Maestro is on the right and is playing an animation that Fusion 360 on the left is actually executing. So this is the type of feature that I would really want to integrate. But unfortunately, although this demo is working and is really interesting, Fusion 360 is not really designed for such an application, and right now the performances and reliability are not there. So this is why I am still looking at how I could integrate 3D visual representation into my application. Perhaps using something like Unity. So I am investigating and we'll see what the future brings. So welcome again to this series, and in the future episodes we'll dive deeper into the concepts of the application. We'll take a look at existing and new features. We'll take a look at the code and at the software architecture of the application. Meanwhile, I want to thank you for watching. If you like this video, please hit the like button below. If you're new to the channel, please consider subscribing. That would help a lot. You can also watch these videos, and until next time, keep creating.